Lesson 2 down the rabbit hole of logic and proof and reasoning and real math is this video right here. This lesson, we are going to be talking about logic today. We're going to be hitting some different vocabulary bits, and we're going to be hitting excuse me, we're going to be hitting some vocabulary, and we're going to kind of learn some statements. We're going to write a lot of English words. We're going to kind of look at an example along the way that'll help kind of illustrate what's going on. And let's dive into it. So the first piece of vocabulary that we are going to define is a statement. Look like that's, there we go. My centering kind of went all crazy. A statement. I'm in the wrong brush. There we go. Statement. A statement. So in logic, a statement is, excuse me, a sentence which has a value of true or false. Okay. So there are lots of things that are not a statement by this definition, right? You could say something like, I don't know, wheels turning, enter meme. I don't know. It's late. I'm trying to get this done and get these videos out and recorded. You could have something that doesn't have a true or false value or whatever else, and that would not be a statement in this kind. It wouldn't be a provable statement, and that's kind of important for what we're talking about. So a statement that has a true or false value is something. So an example of that might be the statement, and we label statements typically with if we have two, we label them. If we have one statement, we label it as P. So we might have the statement P that a rectangle is a quadrilateral. Okay, so that statement has a true or false value. This statement happens to have a value of true. A statement is true in this context if it's always true. That's one of the surest fire ways to figure out if something is false is if you can find a counter example to the statement, then that automatically proves the statement false. So there's not a rectangle out there that is not a quadrilateral, because a quadrilateral is a four-sided closed figure, and every rectangle is a four-sided closed figure, right? So that would be a true statement. Now, we can have the opposite of a statement, and that we call a negation. I'm going to bold up my brush just a tad. Negation. And we say that as not. Okay. And you'll see different notations, the textbook, where you oftentimes you'll see an exclamation point, which like not P. This is not the way we're going to do it. In a lot of programming languages, to negate a statement, you use an exclamation point. Our textbook that we are following for this course in my class and all those things, it uses the tilde symbol. So if I put this, we would say not P. And if we were to continue on with this, excuse me, with this example, not P in this case, I'm going to jump back to this same color, let it match. Not P, that statement would be a rectangle is not a quadrilateral. I'll abbreviate quadrilateral this time since we've got it up above. I didn't abbreviate before because that's a much less common word. So in this case, and every case, the negation of a statement has the opposite truth value. So this is no exception. If we make the statement a rectangle is not a quadrilateral, then that has a value of false. Okay. Again, if we can find a counterexample, and we could find the counterexample to this that would prove it false would be showing a rectangle that is in fact a quadrilateral, and that would disprove this statement. So we can also have a compound statement. A compound statement. There are two typical types of compound statements. Compound statement. Okay. Compound statements are when you have two or more statements joined by the word and or or. Okay. If we have two statements joined by an and, then we call this compound statement a conjunction. Conjunction, junction. What's your function? If you don't know what that is, that's okay. I know what it is because I'm old. If you know what it is and you're young, then it's because your parents or whoever's in charge of you are awesome. Conjunction. How do I spell that word? I got distracted by Schoolhouse Rock. Conjunction. Okay. If a compound statement is joined by an or, and we'll look at some examples of these here in a second. If it's joined by an or, then it is called a disjunction, which makes sense. Okay. So if we now for these things we need to introduce, in order to kind of figure out how the different truth values can work, it's helpful if we introduce the concept of a truth table. A truth table. So let's look at truth tables for these three different types of statement manipulation. Okay, so if we have two statements, statement P and statement Q. Okay, if we have two statements, say like you might have a rectangle is a you might have, well, actually I'll use this example from this textbook. January is a fall month could be the statement P, and statement Q could be January has only 30 days. We might have a fourth statement as well, but we'll add that in a minute. We'll go in with an example. All those kind of things using this is probably good in a minute. We will do that example full out. But here is what a truth table looks like. If we have two statements, for each statement, they can either be true or they can be false, right? So these are the different options for the thing. So P could either be true or it could be false. right? Now, if we have two statements, you could have P be true and Q also be true, right? We could have P be false, but T be Q. Ah, I told you it was late. But Q be true is what I'm trying to get out of my mouth and struggling difficultly, right? We could also have P be true while Q is false. And then finally, one more option. We could have them both, P and Q, be false. Right? If we have two different statements, those are the different possibilities. Those are all of them, right? They could both be true. This one could be false and that one could be true. This one could be true and that one could be false, or they could both be false. So we have three different types of compound statements. One of them is not really a compound statement, but it has a truth table. So the first one that we're gonna write a truth table for is going to be a conjunction. Right? A conjunction has a special symbol. The symbol for conjunction is kind of like an A, but not. So we would say P and, like a capital A without the bar on it, Q. Okay? So I'm going to label that in our notes. Make sure this is clear. We say this and. So an and or a conjunction, it only comes out as a true statement if we're putting the two statements together if they are both true. So our truth values for these, if P is true and Q is true, then P and Q is true, right? This one's true here. If P is false and Q is false, then in order for P and Q to be a true statement in the end, it doesn't work, right? So it's false then. Now, if P is true but Q is false, if we try to put those together with an and, it still comes out false. Because they're not both true. They would have to and it together to be true, right? Or the last option, if they're both false, obviously the and bit is false. Okay. Now, let's see. Let me move this over just a titch because I think I can fit all three truth tables on here. And then we can compare the three, because the one I'm going to shove over here doesn't take up much space. I'm going to, there we go. I'm going to add me a big line. Oops, not that color. Let's take this color. And let's do a truth table for a disjunction. Now, what was the word for a disjunction? It was or, right? So the truth table looks like this. So we have our different possible statements. We have statement P. We have statement Q. And then we have the result, which is P or Q. I'll write that here in just a second. Our different possibilities are the same, right? They could both be true. One could be false and the other true. And the other way around. This one could be true while this one is false. Or they could both be false. Now, for a disjunction or an or statement, the symbol looks like this, first of all. P or Q. So the or is just a flipped upside down A, flipped upside down and, the big old V looking shape, right? P or Q. So it's true if either one of them are true, right? And so the truth table would look like this. They're both true, so the P or Q is true. This one, if just one of them's true, then the end result comes out to be true. And this one, if either one of them's true, the end result comes out to be true. So the only way you can get a false or statement between two, or compound statement between two statements, is if they are both false. So you might notice that and or are inverted from each other. We should also, for completeness, label this as or, right? Now, we have one more truth table that we're going to stick over here because we're going to write a truth table for a negation. That one's a real easy one because a negation, instead of being a compound statement, is just a single statement, right? Negation. And so we're only talking about one statement. So in this instance, we only have a P statement only, right? So its different possibilities are that statement could be true or that statement could be false. Only options if we're talking about a single statement, right? So negation, we already looked at the symbol. We're going to use a little tilde sign. Not P. So you could probably figure this truth table out yourself. If P is true, then not P is false. And if P is false, then not P is true. Let's take a look at some examples, kind of using some of these puzzle pieces and all of those things. So in this first of two examples, we have three statements, right? We went with a P statement, a Q, a P, Q, and R. So the statements are January is a fall month. Statement Q is January has only 30 days. January, and then statement R is January 1 is the first day of a new year. So something that can be helpful, we're going to kind of get a example 1, part A, and part B, and part C. But, excuse me, it can be helpful to start out these by looking at it and figuring out the truth value of the individual statements first. So let's go through and do that. So the first one, January is a fall month. That is a false statement, right? Because January is a winter month, and so that is a false statement. So this guy is false, right? January has only 30 days. Again, that is false because January has 31 days. And then this last one, January 1 is the first day of a new year. Well, that one is actually a true statement because we do have one statement that is in fact true. Now, so part A, let me use a different color so it doesn't get confusing. Have a little kind of scratchy line. There we go. So part A of this example, we want to find the truth value of Q or R. Okay, so when is Q or R true? Well, for an or, only one of those has to be true. So Q is false. Excuse me, Q is false, so it's not looking promising. But then R is true, which makes this statement a true statement. It doesn't matter that the Q is false because we're looking at an or. We're looking at a disjunction. Only one of them has to be true for this statement to be true. Let's look at another one. We're going to do three little bits of this, and then we're going to look at one other type of example, and then we're going to be done. Okay. So for this one, we're going to look at P or Q. Let's see, we can use the word or the symbol. Either one works just fine. So P or Q. So P is false. This is again an or, right? So if only one of them is true, it works. Q is false, so neither one of them are false. Neither one of them are true, which means this is a false statement. We didn't have just even one bit shred of truth in this statement. Not even one little bit, right? Let's do one more from these examples, and then we're going to do another, just basically writing a truth table, of a more complicated truth table. We'll show you in a minute. All right. So example C, or part C of example 1, I suppose. is we're going to write not P or R. Right? Makes sense? Yes? Okay. Good. Good. So for this one we may need to kind of do like a mini like sliver of a truth table, right? Let's see. So not P. Not P will be opposite of that. So this would be a true. And then R is true. So, and actually we didn't even have to do that, both of them, because this one was already true and it's an OR. So that gives us our final value of this is, oh, I was about to write false. I don't know why I did that either. Of true. This statement is true. We didn't even have to check the R because we knew that not P was true to begin with. So let's look at a more truth table. So this one is going to be more abstract. We're not going to have actual statements. So this is going to be example 2. Example 2. And for a problem like this one, it might say something like write a truth table for not P or Q. So that same thing we wrote up there before, but these are more just generic. We don't know what the statements are. This is just given any two statements, P and Q, we're going to write a truth table for different possibilities for not P or Q. So we kind of start this the same way we have been starting our truth tables. We have our two options. We have P and we have Q, right? So that is kind of the beginning. We also have kind of an intermediate step of not P. So we are going to include in our truth table a column for not P. Kind of break this up. So then we can have a column for not P or Q, right? So our options to start out with are the same as they were before. We can have them both be true. We can have a true and a false. We can have a false and a true. Or we can have them both statements be false. Those are the possibilities, right, that they could be. So then for not P, all we have to do is negate or flip this column right here. So this would turn into false, false, true, true. See, we're just flipping the P's to do not P. So now to get this last one, we're going to compare this column with this column. And this is an OR, right? This is an OR. So for this one, it's going to be true if either this first column or this last column is true. I think something interesting is going to happen. You may have already seen what is going to happen. So true, false. We didn't have to read all of that because one of them is going to be true. Right? True, false. I'm comparing the wrong two columns. That's still true. Yay. How about false, false? Not P. If you do P or not P, it will always be true. I told you, this is the third time. It's late. So this is true because I'm still pointing to the wrong column. I need to like mask it off so I can't see it. True, false, true. False, false gives us a false. It's the only way we can get a false if we have a double false on an OR, right? True, true gives us a true. False, true gives us a true. So there's the truth table. That is how you would do a problem like that. Thanks for joining us in this video. If you're one of my students, I'll see you in class. Don't forget to do your homework, all of those things. Have a wonderful day. Y'all be awesome. I'm going to go to bed now.